All right, welcome back. So now there's two problems here, 24 and 25, to help prepare you for practice E homework. So let's read the first one. I got my paper underneath it, so I'll be translating the problem into algebra. Okay, so I got a boat, a sailboat that starts from rest and accelerates at a rate of 0.21 meters per second squared over a distance of 200 meters. I want to know the magnitude of the final velocity, and they want to know how long it takes, what time it takes for the boat to travel this distance. Okay, so we just start translating. Starts from rest, that's the first thing we know. So we know V initial is 0. That's the first thing we know. Then it accelerates at a rate of, looks like I need my glasses again, 0.21 meters per second squared. And it has the displacement. Displacement delta X is 280 meters. So we want to know what the final velocity is. And we want to know how long it takes. That's what we want to know. All right, so one of the, I think the third proof that we went over, the third proof would be, now mind you, there's more than one way to solve any problem, but this one might be a fast one. We know that the final velocity squared is equal to the initial velocity squared plus 2 times acceleration times the displacement. Okay, you guys need a review. I gave you a worksheet that reviews all those proofs. All right, so look, we know what the final velocity is. No, we don't. That's what we're asking for. We know what the initial velocity is because we know it's 0. We know the acceleration and we know the displacement. So this one's just a plug and chug. We just plug it in. All right, so this time I'm not going to say 0. I'm just going to say this one is equal to 0 plus 2 times the acceleration, which is 0.21 meters per second squared, times the displacement of 280 meters. Now, I really want you to pay attention to your units. What happened to my units? I have meters times meters, and I have seconds squared. So I'm going to end up with meters squared over seconds squared. Well, that's good because the answer is going to give us V final squared, not V final. All right, so let's see. What's 2 times 280? My handy dandy calculator here. Turn it on. 2 times 0.21. You can't see that. Times 280. There we go. So this is 117.6 meters squared second squared. This is V final squared. So how do we figure out what V final is? Well, if we take the square root of both sides, then that would be V final. So we just take this, and on your calculator, maybe you guys already know how to do this, but I'll explain here. I'm going to say, give me the square root. There's the button right here. If you guys can see the square root button right here. It's a green button, so I have to do second. There's the square root button, and I don't want to type the answer. Maybe it's really long, and so I want it to be exactly before. Here it says answer on the bottom down here. It says answer, so I'm going to do green button, answer. And now I can say enter. There it is, 10.844. There we go. So I got 10.844 meters per second is the actual final velocity. If you're worried about significant figures, we only have 2 significant figures, then it'd be about 11 meters per second. All right, very good. All right, let's do the second one. The second problem was the time. How long did it take us to do that? All right, again, you guys, there's different equations you can use. I'm going to go with the displacement one. It's not the only one we can use. VI delta t plus 1/2 times A times delta t squared. I like this one in this case only because this whole first term goes to 0 because V sub I, V initial is 0. Okay, so what do I have here? I have 1/2 times my acceleration. My acceleration is 0.21 meters per second squared. Okay, 1/2 times that. And my time, I have to square it. Tell you guys, tell yourself to circle it or something and make sure you square it. So do we know the time? Oh, jeepers. All right, you guys, this is what we're trying to solve for. We're trying to solve for the time. And we know what the displacement is. So from this equation here, we know what the displacement is. We can solve for t. because I can't just plug it in here. All right, so let's try this again. I'm going to write down the equation here is a delta t squared all over 2. Yes? The same thing as this, because I got rid of that part because VI. Now, I want to solve for delta t. I want to solve for delta t. How can I isolate it? Well, what happens if I multiply both sides by 2? Okay, that gets rid of the 2 on the bottom there. What happens if I divide both sides by a? Divide both sides by a. Now I get 2 delta x over a is equal to delta t squared. Delta t squared. So basically, these equations will give you whatever you want. You just manipulate it to the variable that you want it, if you know what the magnitude is of the other variables. All right, so let's plug it in. 2 times delta x, which is 280 meters, and the acceleration, which was 0.21 meters per second squared. Now, what does that mean? Meters per second squared in the denominator. Well, let's make sure. Let's see. I got meters divided by meters per second squared. I like a complete fraction. Now I multiply the inverse. So m over 1 times second squared over m. Okay, so my meters cancel out and I end up with second squared. Eventually you'll notice when you have a downstairs in the downstairs, that goes upstairs. All right, so what do I have here? 2 times 280 divided by 0.2. Let's do that. I wish I could show both at the same time here. 2 times 280 divided by 0.2. Ay, caramba. 0.2. And I get 2,800. 2,800 seconds squared. Okay, seconds squared. And that's not what I want. So I'm going to have to square root it. What happens when I square root this? I'm going to square root this. Did I multiply this correctly? I always do it twice in a row. 2 times 280 divided by 0.21. That's what's wrong. By 0.21. They gave us acceleration as 0.21. There we go. 0.21. Okay. So it helps if you write it correctly. So now I have 2,666.666666, etc. All right, that's my t squared is equal to t squared, delta t squared. So I'm going to square root both sides. So I know that delta t is going to be, here we go. I'm going to say second square root, and I don't want to type all that, second and answer. There we go. And I get 51.639. So 51.64, let's say, seconds. And if you have to have just 2 significant figures, then it's about 52 seconds is delta t. And that's it. So glad I made that mistake. You just start, blah, 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 plugging along, but we have to pay attention to what variable we wanted. So that's when I went, right equation, but I need to isolate the variable and figure it out what it is that I want. So again, in this case here, it was at rest. Here's the acceleration. Here's the displacement. So we're able to plug it into this equation to figure out what the V final was. But it actually gives you V final squared. So we had to square root it. Now when we square root it, then we get 10.84 or about 11 meters per second. All right. Now they want to know how long. Well, in this equation, we have, let's see if I can underline stuff. We know what the displacement is. We know the acceleration. This part all goes to 0. The only thing here we don't know is delta t, or delta t squared. So this one is a good one as soon as we manipulate it around to what we want. And we found that delta t squared in this case was 2 delta x over a. Now, if the initial wasn't 0, it would still be here. We'd have to include that in there. We'll do that in a different problem, sure. All right. And you plug it in and get the square root of delta t squared to find out what delta t is, and you get 52 seconds. So that's it for practice E, and I'll see you next time.